All right, good morning, good afternoon, good evening, wherever you are. Hope you're doing great. Going to walk you through here how to figure out the lateral and surface area of a prism. But before we do that, I'm going to go ahead and kind of give you some background information on some things I need you to know. So first of all, I'm going to go ahead and get rid of, do one thing here. Click on that. There. Let's see if this works now. You can go and get rid of this problem right here and this problem right here. Those are pretty basic problems, and we don't need to do those. We're going to work on some more complex problems today to make sure we've got this understanding down. But the first thing I want you to put down here at the very top, surface area. Okay, and I want you to write down this definition of surface area, and I'm going to refer back to this as we go along today. It's the area of any face you can physically touch. Okay, if you can think about that, if I can touch it, I have to add it into the area of the surface. I think that definitely helps as we work through this understanding of surface area. Yesterday, we highlighted two concepts around the base faces. So let's write that down, base faces. Okay, and so the two concepts you can write out here, 1, 2. The first concept, that they are always parallel to each other. Okay, so go ahead and write that down for the first one, always parallel to each other. And the second one is that they're always congruent to each other. All right, so again, I'm going to be referring back to that as well. And then very simply, again, we talked about this yesterday, a lateral face is any face that's not a base face. So again, any face that is not a base face. Okay? So as we go through these problems here, those three concepts are going to prove to be huge for our understanding of coming up with the surface area formula. So the first thing I want to do, let's go down here to number 3. I want you to go ahead and draw the net of that figure. Now, if you draw it like we did yesterday, we went ahead and took these lateral faces and put them out as they were. So if I go ahead and draw that, okay, 5 by 22. I wish I could use my marker on this, not the pen tool that I'm using because it's not as accurate. But we've got one of those rectangles, and if you notice, there are 8 of those rectangles consecutively. So I'm going to go down here and see if I can see if that's enough space there. So it's 2, 3, 4, 5, 6, 7, we'll say something like that, 8. Okay? So let me double check that, make sure I count that right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. And then off the side of one of those rectangles, we're going to go ahead and put the 2 base faces. So we've got 8 sides there. Something like that. Okay. Oh, I don't know why that did that. Hopefully it'll go forward. Well, interesting. And then I want to make sure I label all of my dimensions. So these are all 5 centimeters. Okay, and as are these. Okay, and then these are all 22 centimeters. Okay, now let me just make sure this is clear as well. Beyond the 3 concepts that we covered already, what a base is, what a lateral face is, and what surface area actually is, we're trying to work towards the formulas here. So we're going to be doing these. And the reason why is because as you look at group number 4, that problem, number 5, and number 6, those are harder problems. And we don't want to have to do more work than when we have to. We want to work smarter, not harder. So as we look at that, there's the net of my figure, and I'm going to figure out what the lateral and surface area will be here in a second. But let's go to actually group number 4 and do that one as well. Figure out what the net will look like in that one. Now, the only two sides that are parallel and congruent is this L-shaped figure right here. Okay, any other sides aren't both parallel and congruent. So what I'm going to do is I'm going to draw out that L-shaped figure so that we can have that as our base. So it looks something like this. Okay, so there's one side. We can consider that the front side of our picture right there. Okay, and I'm going to go ahead and connect it with the bottom side. And then mirror that on the other side. And we'll say that's the back side. Okay. Now from here, all these sides that go around on the outside, I'm just going to list in a line right here, and I'll show you why in just a second. So this side, this length here has to correspond with that length. This length here has to correspond with this length. This length here has to correspond with the next length. Okay. And this length here has to correspond with the next length. Excuse me. Allergies are killing me this year. And then this length here has to correspond with the next one. Okay, so as we bring it all back together, it all meshes. Now, what's going to be difficult about this one is there's so many different dimensions, and it's going to get very confusing with our markings here. But we know that this length is 22, so this length right here is going to be 28 minus 22. So this length right here is 6 meters. Okay, we know that this length is 24. We know this is 36, so this length right here is going to be 12 meters. Okay, so from there, if I fill those in, let's see here, the bottom was 36. Okay, we know that the connecting distances were 18, so that would be this length down here. All of these, 18. So 18 meters. Okay. We said that this was 6 meters. Okay. We know that that next one is 12 meters. Okay. The next one, this length here, and that one there, 22 meters. Okay. This one is 24 meters. Oh. I don't know why that keeps doing that to me. Hopefully I don't lose it one of these times. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh. Okay, and then the last one is 28 meters. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can see there's a lot of work involved there if we try to go ahead and do the net of the figure, but it's always possible if you want to do it that way. Now, how do I find the lateral area? Well, the lateral area, as we said yesterday, is going to be the sum of the areas of all of these faces right here. Okay, and so if I go ahead and take 22 times 5, that would give me the area of one face, times 8, that's going to give me my total lateral area. So 22 times 5 times 8 gives me my total lateral area. If I work that out, you get 880 square centimeters. Okay. For the surface area, okay, we get 880 plus, there you go, plus the area of one of these faces doubled. So I'll put 2 in the area of that face doubled. Now, the area of that face, it might be easier for me to do it down here. If I go ahead and find one of these triangles here and multiply it by 8, I can get the total area. And so what I'm looking at here, I'll just draw the right triangle here because we're going to need to use trig functions for this, I believe. I'm going to find the central angle. Okay, and that's going to be 45 degrees. Okay. And so this angle right here is going to be half that, 22.5. Okay. Now, if that's 22.5 degrees, I know that this length is 2.5 centimeters, half the 5. And I can find the height by doing my tangent function. Okay, so we're looking at the tangent of 22.5 is equal to 2.5 over h. Okay. Now remember, whenever you have an unknown in the denominator over here, okay, you can work through all the algebra, but it's just going to be 2.5 divided by the tangent of 22.5. Tangent 22.5. Okay. So from there, if I work this out, we're looking at 2. Now there are going to be 8 triangles here. Okay. And each triangle has an area of 1/2 the base, which is 5 centimeters, times the height, which is what we just found. Okay. 2.5 divided by the tangent of 22.5, you can't read that. Okay. Again, my apologies for the sloppiness of that. So from there, let me think here. I may actually have to calculate that on my calculator. If you work that out, let's see what that's going to give us here. Okay. When you work that out, you get 1,121.4 square centimeters. Okay. Now, let's talk about the next one, then we'll come back and look at the formula here. For the lateral area of this other figure, obviously much more complicated in drawing it out, but the lateral area and surface area actually are probably easier than the previous one. So your lateral area is going to be this, the area of all these areas added together. Okay. Now if I do that, let's see here, we have 18 times 5, that would be this one, oh, I said that wrong, didn't I? 18 times this one, which is that length there, 24. This one is 18 times 1 back, 22 times. Okay, the next one is going to be 18 times 12. Okay, this one is going to be 18 times 6. Okay, the next one's going to be 18 times 36. And then the last one is 18 times 28. Okay, now if we work that out, you should get 2,484 square, oh, meters, not centimeters. Okay. So that's the lateral area. Now the surface area, it's actually, we'll take the surface area, which will be that lateral area, and we're going to add in twice the base area. Now the base area, I'm going to bring down here just a bit because I can't write it all in up there. I would probably break up the base into two rectangles here. One's a 22 by 24 rectangle, and the other is going to be, what are these dimensions, 6 by 12? Okay, that's what would go in the parentheses up there. All right, and if you work that out, let's see here, 24 by 28. Oh, you know what? Just realized something. This whole length isn't 22, it's 28. So let's change that to 28. There we go. Okay, and 6 by 12 would be correct. Let's see here. I think I made a miscalculation with the first one. I'm going to double check that real quick before we go on. 18 times 24 plus 18 times 22 plus 18 times 12 plus 18 times 6 plus 18 times 36 plus 18 times 28. 2,304. That looks better. Okay. So let's change this. 2,304. There we go. Okay. And then for the other one, if we're going to add in both bases, 2 parentheses 22 times 28 plus 6 times 12. Okay, so the total surface area here is going to be 3,680 square meters. Okay, so as of right now, we've got everything laid out for us. We've got the total surface area and lateral area. Now, why did I have us go through all that? The reason is because I want to make sure that we had something to go back on when we're checking these formulas here. So your lateral area formula for a prism is going to be this. Perimeter of the base times the height. Okay, I want you to write that out actually. Perimeter of base times the height. Okay. Now, the perimeter of the base in the first one is really simple. It's just going to be 5 times 8. So if we look at this, there's your perimeter of your base. And we're going to multiply that by the height of the figure. Now the height, you might want to take a note on this as well. The height is the distance between the two bases. Okay? So in this case, it would be 22. And so as we look over here, this one, if I take my perimeter of my base without drawing out the net, here's what we have. We have 28 plus 36 plus 24 plus 22 plus 12 plus 6. Okay? So if I was to take that and add those up there, we end up with this. Okay, 128 is the perimeter of that base. Now, if we take the perimeter of that base and multiply it by the distance between the two bases, which would be 18, 128 times 18 should give us that 2,304. So let's see here, 128 times 18, 2,304. Okay, so that's an easy way to figure out your lateral area. Okay. Now, as far as your surface area of your prism is concerned, so surface area of the prism is going to be your lateral area, which you saw that in every single one of them, 880, 2,304, okay, we used it again, plus twice capital B. Now, capital B is the base area. So whatever the area of the base is, we're going to double it. Now, this one right here, we already saw that. We took the area of one base and doubled it. Over here, we took the area of one base and doubled it to get your total surface area. So again, we're going to use those two formulas to figure out the lateral and surface area of our figures. All right, so with that being said, let's go on to the back side here, and let's take a look at two more problems using our formulas instead of our nets, because like I said, the nets are just, they take a lot longer to do. Okay, now obviously these two figures here are pretty complex, and so can be kind of difficult to work out. So if I was to go ahead and draw the net of this figure, I'm not even going to try, but the lateral area formula, let's start with that. The base of our figure, this face right here is actually the base, because it's both parallel and congruent to the opposite side. And so I'm going to go ahead and take the perimeter of that base, and if I do that, 4, 5, 6, 7, 8, 9, I did that wrong, 4, 5, 6, 10, 11, 12, 16, 17, 18, 22, 23, 24, okay? So there would be 24 x's there as the perimeter of my base. And I want to multiply it by my height, so P times H, okay? Now my height, again, is my distance between the two bases, so 3y is my height. Now you may be thinking to yourself, I can't combine those, they're not like terms. Well, remember, you can multiply in like terms, you just can't add or subtract them. So if we take 3 times 24, that's 72. XY would be your lateral area, okay? Now for your surface area, you're going to take the lateral area and you're going to add in twice the base area. And now I've seen lots of different ways to go ahead and find the area of that base right there. You could go ahead and complete the square like this. Okay, find the area, so this would be 6x, right? X plus 4 plus x, so 6x. X plus 4 plus x would be, again, 6x. So 6x squared, I'm sorry, just 6x times 6x would give you 36x squared, okay? And then you can subtract out x squared, x times x squared, and x squared. So if you subtract out 4x squared, you get 32x squared. Okay, that would be one way to go ahead and do that. You could also go ahead and break it into rectangles and squares on the inside. Actually, I think it's, yeah, I've seen students do this. Okay, so 3 rectangles. I've also seen students do this. Okay, 4 rectangles in the square. If I do the 4 rectangles in a square, this would be 4x squared times 4 plus, and then this would be 4x by 4x. So you would end up with 16x squared plus 16x squared, which would be 32x squared. Okay, so either way, it doesn't matter how you do that, but we're going to have 32x squared as one base, and if we double that, you end up with this. I wrote that last part wrong. That should be like this. There we go. Okay. All right, so again, we're just doubling what we have there. All right, so that would be your lateral and surface area of that one. I did draw the net out just to show you if you'd want to ever take a look at it, but it can be pretty complex to do that. Now for the last one, let's go ahead and take a look at this one, because the one concept from this last one that I want to make sure everybody gets down is the fact that lateral or surface area is anything you can physically touch. So we're just going to do the surface area of this last shape. Now, I would go ahead and use this top and bottom side as my base, okay? And so what I'm going to do, the top side for surface area, I'm going to do the lateral area of the outer figure, okay, so this outside portion. If I do that, this would be 4x and 3x, that'd be 7x another 7x. So 14x is the perimeter. And we're going to multiply that by the height of the figure, which is going to be 5x. Okay? That's the lateral of the outer. Okay? Now, what I want you to see is there's an inner part here as well. I can physically touch down inside of that. And so I'm going to actually do the lateral area of the inside as well. And if I do that, the perimeter of the top base is going to be 2, 3, 4, 5, 6x. Times again the height, which is 5x. Okay, that gives you the lateral area of the inner. All right, so we've got the lateral of the outer, lateral area of the inner, and now we have to find the area of both of these faces. Okay, the top face and the bottom face. How am I going to do that? Well, twice capital B, the base area. I'm actually going to find the area of this rectangle out, and then I'm going to subtract out the inner portion. The area of the rectangle would be 4x by 3x, and subtracting out the area of the inner portion would be 2x by x. Okay, if we work this all out, this should give us our total surface area. So this is going to be 70x squared, 30x squared. That would be 12x minus 12x squared minus 2x squared would be 10x squared. Times 2 would be 20x squared. Okay, and so in the end, the total surface area, 70 and 30 and 20 make 120 x squared for the total surface area of that figure. There was some algebra review there that I wanted to make sure that you saw, but on top of that, I wanted to make sure that you understood that surface area is anything you can physically touch, so that inner part has to be calculated into the total surface area. So, with that being said, I have a couple of problems I'd like you to work on online, and so get those done for me, and then we will see you tomorrow. Have a great day.